we're going to look at an introduction to simultaneous linear equations. This is actually about finding the intersection point of two straight lines. This subtopic name, simultaneous linear equation, comes from the method used to find this point. Now, before I show you the ways that this can be done, let's consider the possibilities when there are two straight lines graphed on the same graph. If you remember the rules for equations, you will also realise that the rule of a straight line can be manipulated so it looks different. So, if you have two rules, it is possible that they are actually the same straight line. This would mean that they have an infinite number of intersection points because they lie on top of each other. Consider these two equations. Y equals 0.5x minus 2 and 2y minus x plus 4 equals 0. They're both straight lines. Let's use GeoGebra to have a look at them. Okay, so we type the first rule in at the entry line and press enter. There it is. It's our straight line. We'll just move the whole thing up a bit like that. So we hit the move button, move it up. Then we'll type in the second rule, which was 2y minus x plus 4 equals 0. And press enter. And did you notice that it just lies on top of the other line? So this is in fact the same straight line. And if we're looking at their intersection points, well, it's an infinite number of intersection points, all of them on that line. Okay, another possibility is you have two rules that have the same gradient, but have different y-intercepts. If this happens, the lines would actually be parallel to each other and never cross over. So there is no intersection point. Consider these two straight lines. Y equals 3x plus 1 and y minus 3x equals 4. Again, we'll use GeoGebra to check them out. So first one is y equals 3x plus 1. There it is. And the second one is y minus 3x equals 4. There it is there. Now you can see these two straight lines, they have the same gradient. They have different y-intercepts. That means they will never cross. If we move this both ways, you can see no matter where we go, these two straight lines never cross, and therefore there are no intersection points at all. Okay, the third possibility is that you have two different rules, each with a different gradient. In this case, they will intersect at one unique point only. One unique x value, one unique y value. Let's consider these two straight lines. Y minus 2x equals 1 and y equals minus 3x plus 2. Again, we'll use GeoGebra to check them out. Okay, so there's our first line. Y minus 2x equals 1. There it is. I might just move these back down a bit so you can see the axes. There you go. And the second one is y equals negative x plus 2. And press enter, and there it is. There you see that one unique intersection point. Now on GeoGebra, we can look for a command which is called intersect. So we'll find that. Okay, so on that tab we just press, we've got all these options. We choose all commands, it's just easier. We'll go down to I for intersect. We intersect A, comma, B, because if you notice there are two lines we put in that were given a label by the program A and B, and then we press enter, and that point A is displayed on our graph here, and the coordinates of that point are shown here, so 0.33 and 1.67. And you notice they're rounded off. They don't actually give us the exact answer. Okay, that's an introduction to the meaning of simultaneous linear equations.